This video is on 13.2, which is absolute value functions and transformations. This has to do with what we did in class on Friday, which was investigating absolute value graphs, which were those V-shaped graphs. So if you guys need to at any point, obviously you can pause it and rewind or fast forward if I'm going too slow. So feel free to do that, and then there will be a hard copy of the notes as well. So this is our general equation for an absolute value graph, which is kind of what we started investigating, but we didn't talk about what each piece actually meant. So there's this first, we have A, H, and K, and all of those are just variables that are representing different types of transformations for an absolute value graph. So this letter A is going to represent the slope. So think back to when we studied transformations of lines. The bigger the number, the steeper the slope, and it works exactly the same for absolute value. However, it doesn't matter whether it's negative or positive. So if it's -6, it might be facing downwards, but it's going to be extremely narrow. So if you have the absolute value of A is greater than 1, so you're really just looking at the value of the number, then that would be considered a stretch. But if you have a number that is between 0 and 1, then that would be considered a compression. So a compression will make it wider, and a stretch will make it more narrow. We also have this letter H. So H is representing the horizontal translation. And on Friday, a lot of you guys were discovering that it was always the opposite. So for example, if it said something like x plus 3, that actually means it's moving 3 to the left. Or if it said something like x minus 5, it's actually moving the graph 5 to the right. So I'm going to just, in parentheses, say that it moves it left or right. And then I'm going to clarify that it's actually the opposite of what you would think. And then lastly, this was actually the first transformation that we studied, is K. It's the vertical translation. So the vertical translation moves it up or down. And that one is as is. In other words, it's not the opposite. Okay. So with that, that means that HK, since that moves it left or right and up and down, that's the vertex. Remember, we talked about the vertex is the point where both lines meet. And then lastly, if we have a negative A value, then that would be a reflection. So meaning it's now flipped over the x-axis, but all we would really have to say is reflection. Okay, so what we're going to do is investigate the parent function. So the parent function is the most basic function before transformations have occurred. So you can go ahead and pause this, for example, while you're setting up your table graph and writing the words domain and range. And then once you are ready, we will go through this together. So I'm going to go ahead and plug in some numbers for x so I can get some outputs. So I'm just going to plug in -2, -1, 0, 1, and 2. So when I plug in -2 into the equation, it would be the absolute value of -2, which is just 2. Remember, absolute value is the distance from 0. When I plug in -1, the absolute value of -1 is 1. When I plug in 0, it's 0. When I plug in 1, it's 1. And when I plug in 2, it's 2. So then we're going to go ahead and graph this. I'm just plotting all of the points. And we should kind of already know what shape it is because we looked at this on Friday. So it makes a V-shaped graph. So a lot of people were saying like a straight parabola, but this is a completely different type of function. So absolute value graphs are V-shaped graphs. So then we're going to identify the domain and range. So domain is all possible x values and range is all possible y values. So if you look at this, the domain, it's going to the left and to the right forever. So we're going to just use that symbol for all real numbers. And then for the range, all possible y values, it looks like it's all positive, but it also includes 0. So we can say y is greater than or equal to 0. For the rest of the notes, what we're going to be doing, we're looking at 3 different graphs here. So we are going to graph them, identify the transformations, and then identify the domain and range. So you can go ahead and pause it and go ahead and copy what's on the screen and then push play when you're ready. Okay, so for this first one, we have f of x equals the absolute value of x minus 1 plus 4. So kind of going back to the parent function, we want to see what's different. So I see that there's an x minus 1 inside the absolute value. According to what we looked up at here, it says that h moves it right or left, and it's always the opposite. So because it's x minus 1, that would mean that it moves to the right one. And then we have a plus 4 on the outside, which would mean that it goes up 4. And then lastly, we can identify the vertex, which is hk. So since it's negative 1 in the absolute value, I know it's 1, and then the k stays the same. So instead of plugging in points, which we could do, and we could always do, there's actually a much easier way of doing this. So how I do it is I start with the vertex. So the vertex is at 1, 4. So I go to the right 1 and up 4. And then from there, you look at what your slope is. So technically, there's no number in front of the absolute value. So there's really a 1 there. So that means that the slope is 1. So from the vertex, you would just go up 1 over 1 on both sides and up 1 over 1. And then I'm going to keep going. I'll do a couple of points. So up 1 over 1, up 1 over 1, and it will look something like this. So it looks like the same exact shape as the parent function, it's just been translated. The domain is always going to be all real numbers. That will not change, so that's kind of like a freebie. Your range is going to change based on where your vertex is. So in this case, your range would be y is greater than or equal to 4. And that would be it. So looking at the next one, f of x equals 2 times the absolute value of x plus 3. This time we do have something in front of the x. It's a 2. So that is going to stretch the function by 2, meaning it's going to become more narrow. We are not moving it right or left at all, but we are moving it up 3. So to find the vertex, it's always hk. Well, since there's nothing inside the absolute value bars, it would be 0. And then we still have the 3. So just like last time, you start at the vertex. So the vertex is 0, 3. So I'm going to put a point there. And then I go according to my slope. So this time the slope is 2. So I'm going to go up 2 over 1, and then I do it to the other side from the vertex, up 2 over 1. And I don't really have enough room, so I'm just going to do that much. So you can see that this one is a little bit more narrow. It's actually 2 times as steep. And then the domain is a given. It's always all real numbers. And then the range is y is greater than or equal to 3. And our last example has quite a bit happening here. So the first thing I notice is that it has a negative symbol, which we haven't looked at, but we talked about at the beginning. What that means is it's a reflection. So all of the absolute value graphs that we've looked at so far open up, but this one will open downwards. Then we have a 1/2, which would be a compression. So what that means is it's going to be less steep, so it'll be more wide. We have an x plus 2 inside, so that means it's going to go left 2. And then we have negative 2 on the outside, which means it will go down 2. So as always, we start with figuring out what our vertex is, because that's the first point we graph. Just like for a line, the first point we graph is a y-intercept. So the vertex, we look at this and this. So it's x plus 2, so it'd be negative 2, and then that stays the same, so negative 2. And I'm going to put a dot there, so negative 2, negative 2. So that's my starting point. And then from there, you just look at this piece, which is negative 1/2. So I'm going to take care of the compression and the reflection at once. So instead of going up 1/2, we just go down 1/2. And I can do it on the other side. And so you'll see that it's facing downwards, and then it's also way less steep. And then our domain is always all real numbers. And then our range this time will have to be y is less than or equal to something because it's facing downwards, and it is less than or equal to negative 2. So this section basically covers graphing absolute value as well as identifying transformations of absolute values. And that's it.